We now take the same problem as in the previous lesson, and let's assume that in this case we know the x displacement is 300 meters and we know the y displacement is 50.8 meters. And we also know that the initial speed of launch is 70 meters per second. And in this case we are asked to find the angle of the launch theta. So you could think of this problem as a projectile is fired at 70 meters per second and this strikes the top of a building of height 50.8 meters, which is 300 meters away, and we have to find the launch angle. Since the x and y displacements are present, we should be thinking in terms of the trajectory equations. But which one should we apply? Here, since we have to find the launch angle, it would be most convenient to work with the third equation, where tan theta would be the only unknown. So let's try it out. So now the projectile strikes the top of the building and we use the equation y equals x tan theta minus gx squared times 1 plus tan squared theta over 2v0 squared. And we are given y, we are given x, we are given v0, and we know g is 10. And we have to find theta. So we really have to find tan of theta from where we would get theta. Now we make the substitutions. 50.8 is the y displacement, 300 is the x displacement, 70 is the initial speed, and 10 is g. And we get a quadratic in tan of theta. So let's solve for tan of theta. And this is interesting because we get two values for tan of theta, 70 degrees and 30 degrees. So which one would be the correct answer? Or is it that both are correct? Now we are quite sure about the 30 degrees one, since we solved the previous problem with 30 degrees and we obtained the y displacement as 50.8 meters. So 30 degrees is an expected answer based on our experience from the previous lesson. But let's watch the animation of how this would appear like. So when we launch a projectile at 30 degrees with a speed of 70 meters per second, the projectile strikes the top of a building of height 50.8 meters, which is 300 meters away. Now what about 70 degrees? Would that be a valid answer too? Let's watch the animation where the launch angle is now 70 degrees. Where would this land? And oh, it strikes the top of the building, just like the 30-degree launch, with the same initial speed of 70. This means that both these answers in solving the quadratic equation are correct. Even if we launch the projectile at 70 degrees with an initial speed of 70 meters per second, it would strike the top of the building of height 50.8 meters, which is placed 300 meters from the launch point. Whenever we need to find the launch angle and we are given the x and y displacements, we use the third form of the trajectory equations. From this example, we have seen that it is quite possible that two trajectories having the same initial speed but having different launch angles could happen to have the same y displacement for a given x displacement.